All right, so we have been studying a lot about the sine curve. We know a whole lot about the sine curve, and today we're going to continue on and learn a little bit more, actually introduce the cosine curve, and then how these two things fit together, how sine and cosine are connected to each other, okay? So we have calculators, we have our unit circles, we have that half sheet of paper on how to graph trig functions, and we're all set to go. So I'm going to begin by talking about the parts of the cosine curve, similarly how we began by talking about the points of the sine curve. Okay, so here we go. So first thing you should do is give yourself a pretty decent sized coordinate plane worth 1 unit circle rotation, right? Worth 1 unit circle. So if this is 0, this is going to be 2 pi. Okay, so I want 1 full row positive rotation of the unit circle. Remember that we're just basically unraveling the unit circle in a circular motion onto a linear xy coordinate plane. The x's represent our radian measures, the y represents the outputs, okay? So that's 2 pi, halfway between there has to be pi, a quarter of the way is pi over 2. That means that this is 3 pi over 2. All of this should look very familiar to you so far. Is that true? We good? All right, I'm going to go up to 1, and I'm going to go down to negative 1 right here, okay? I think that's about right. All right. Now, please take a look at your unit circle. You have a unit circle in front of you. We are interested in the cosine, okay? And remember, we're going to travel around the unit circle, and we're going to pay close attention to the cosine values. Are cosine values x's or y's on the unit circle? I have one person who kind of thinks they're x's. What are they, guys? X's or y's? They are indeed x's. They are indeed the x values on the unit circle. So, look on the unit circle right now. Tell me, what is the cosine of 0 radians? Yeah, it's 1. Does everyone see that it's 1? Okay, and the cosine of 0 radians is 1 because the x value of the coordinate at 0 radians is 1. So therefore, one of the points on my cosine graph is the point 0, 1. Okay? Now remember, these are broken up into quadrants, right? These are all the quadrants in one full rotation of the unit circle. This is quadrant number 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Okay? It's all broken up in terms of quadrants. We're going to travel around the unit circle going counterclockwise. Let's go over to quadrant angle of pi over 2. What's the cosine of pi over 2? It's 0. So I know that the point pi over 2 comma 0 has to be on the curve of the cosine of x. Do you see how this is taking shape? Very similar to the sine curve, right? We're establishing our 5 dots that we use to sketch cosine curves. Okay, what's the cosine of pi? Let's go all the way around. Keep going. Kind of fun, right? Negative 1, right? Cosine of pi is negative 1. Very good. So I know that the point pi comma negative 1 is on the cosine curve. Let's go to 3 pi over 2. 0 again, right? Good. And then let's finally go all the way back to 2 pi. What do we get? 1. Very good. So ladies and gentlemen, we have just examined 5 points on the unit circle and calculated the cosine of every angle. We did the cosine of 0 is 1, the cosine of pi over 2 is 0, the cosine of pi is negative 1, the cosine of 3 pi over 2 is 0, and finally the cosine of 2 pi is 1. How many points theoretically are on the unit circle? And infinite. How many did we just calculate? 5, okay? So if we actually took the time to calculate every single radian degree measure from 0 to 2 pi, which of course would be impossible to do because there's an infinite amount, right? We would end up with this curve right here. And this is the shape of our cosine curve. So what do you notice right away? What does it look kind of like? A noodle, a V, yeah, okay. I was thinking more specifically towards math, but you're on the right track. Okay, more specifically to something that we've already done. It kind of looks like a sine curve, right? It kind of doesn't it look like the sine curve a little bit? It's not. It looks like. I'm going to show you something in a little bit that's going to blow your mind, hopefully. But this is kind of cool. So I can now ask you some questions about this. But before I do, the sequence that we should remember for a cosine curve is high, middle, low, middle, high. Yeah, see what I just did there? High, middle, low, middle, high. That's one full sequence, one full period of a cosine curve. Okay? So now I'm going to ask you a bunch of questions about this particular cosine curve. First of all, what is the period? Yes, very good. Not a trick question. The period is equal to 2 pi. It's the exact same as what? Sine curve. So therefore, sine and cosine both have a period of, fill in the blank, 2 pi. Very good. Awesome. What's the range? What's the range? No.
The range is from 0 to 2.
No.
1 to 1. 1 to negative 1.
Negative 1 to 1. The range is the y values. The range goes from negative 1 to 1. Okay? What's the domain? There you go, buddy. Nice job. The domain, of course, is all real numbers, meaning all real radian numbers. I could take the cosine of 79.35 pi over 14 and I could get an answer, right? There's no value for which I cannot take the cosine of, right? Cosine 0 is good to go. Cosine 90 is good to go. We could figure it out. So therefore, the domain's all real numbers, okay? Is there any symmetry cosine curve? Do you see any symmetry anywhere? Yeah, like Jake just said, right down the middle. So if I actually took the cosine curve, remember now this curve continues on like that in the background. So if I took the cosine curve and I folded it in half right on the y-axis, I would get a mirror image. Do you guys believe that? Absolutely. So you don't believe it? Oh, okay. I will show you. So there is symmetry, okay? There is symmetry with the y-axis. That's because cosine of x is what's known as an even function. Not necessarily important for right now, but cosine's an even function, meaning it has symmetry with the y-axis. Don't worry about that part for right now, though. Just something interesting there. Okay. In which two quadrants is the cosine curve negative? 2 and 3. Hank, how do you know so fast from looking at that? They're just below 0, right? Which two quadrants is the cosine curve positive? 1 and 4. Very good. Awesome. Which two quadrants is the cosine increasing? Not all. From 3 to 4, it's increasing. Remember, we define increasing as x goes left to right, y values go bottom to top. Increase. Okay? So another way we would say that is the cosine is increasing from pi to 2 pi. See that? From pi to 2 pi. That denotes quadrant 2 to quadrant 3. I mean, sorry, 4. Excuse me. 3 to 4. Excuse me. Now, where is the cosine curve decreasing? 1 and 2. And what's the other way that we could say that? From 0 to pi. Perfect. It's perfect. Okay, nicely done. Okay. Before we do this little activity here, I do want you to take out your calculator right now, please. Okay? Take your calculator out. Okay? Take your calculator out. Put this over here. I'll bring this into view, okay? I want you to clear all this out. I want you to put your calculator in degree mode, please. Okay, put your calculator in degree mode. So go to mode and put your calculator in degree.
When it comes, like, is it in degree or radian?
I think when it comes, I think it's in radian, actually. I think so, yeah. Okay? Okay. Okay.
Does it change anything else besides when?
No. It doesn't affect anything else. All right, ladies and gentlemen, here's what we're going to do together. I want you to punch in the sine of 70 degrees. Okay, everybody punch in the sine of 70 degrees and push enter. So I'm getting this. You guys are getting the same thing? Because we're in degree mode, right?
Sorry.
Oh, didn't need to see that. Okay. Now, I got the sine of 70. Now, everyone punch in the cosine of 20. What do you see? The exact same thing. Okay, punch in the sine of 10.
Coterminal thing? Yeah. It's like the triangle.
It's like the triangle thing. Okay, so punch in the sine of 10. Punch in the cosine of 80. And what do you get? Is this true for all of them? That's true for all of them, right? Cosine 80, right? Same thing. What's going on here? Why is
They
this?
all equal up to 90.
They true. 80 and 10 are 90. And sine or cosine are,
X and Y.
well, they are cofunctions of each other. Sine and cofunction. Okay. But what I'm about to show you is I want to show you why this is true. Okay? So I wrote this little thing in Desmos for us to do. And if you have it, follow along. If you don't, just watch what I'm doing up here, okay? So check this out. First, I'm going to go to projector mode to make the graphs a little bit bigger. What outlined graph do you see here? Sine x, right? And what are the 5 dots that we use to sketch the sine curve? 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then lastly what? 2 pi 0. Okay, good, great. Now here's what I'm going to do, all right? I'm going to put on the graph for us the points that we used for the cosine curve, right? And the cosine curve that we used, what was the sequence that we did? How does the cosine curve start? See my green dot just appeared?
0, 1.
See where my green dot appeared? Then what's the next one?
Then,
Pi over 2, 0. Good. Okay, what's my next one?
Pi negative 1.
Pi negative 1. So look at my green dots, right? My green dots are appearing. Then what?
3
And then 3 over 2, 0. And then,
I don't like that at all.
0, 1.
okay. It's okay if yours is not like that. It will be in just a second. Just watch mine for right now, okay? Okay. It might not be like that because of where it left off last time. But don't worry about it. Just follow along what I'm doing up here, right? Do you see how those green dots have now outlined the cosine curve? Okay, now what I'm going to do is I'm going to put the cosine curve on the graph. Hey, there it is right there.
Oh, I think I turned up.
They're not the same. They shouldn't be the same. The black line,
Mine's the same.
don't worry about just everyone close your computer screens. Yeah, it's getting confusing. Just watch mine, okay?
No, they're the same.
Okay? Close your computer screen. Just watch mine because mine's where it should be, okay? The question that we're trying to answer was this, right? Why was it true that the sine of 70 was the same thing as the cosine of 20? Or the sine of 10 is the same thing as the cosine of 80?
By that much.
Yes, you're noticing that these are kind of similar to each other. They're just off by a certain amount. How much are they off by?
Sine of whatever equal, I don't know, minus 90, something like that.
90 degrees, right? And what's 90 degrees as a radian, you guys?
4. Oh,
No, pi over 2. Okay, now watch this. Watch this. I'm going to put, hey girl. Okay, here's what I'm going to do. I'm going to put a little line segment on the graph. Do you see my orange line segment I put on the graph?
Yeah.
What is the distance of that line segment? It's pi over 2. Look, it goes from 0 to pi over 2. It's the distance, which is 90. Now watch this. Look, I'm going to put all these orange little line segments on here.
We're making a roller coaster.
Okay, now, check this out. Check this out.
Oh, it's like
The point I'm trying to make,
No, it's like dancing.
the point I'm trying to make is that the cosine curve and the sine curve are exactly the same, except they are a phase shift by how much out? By pi over 2. Now watch this. The sine curve is going to pull the cosine curve into it. Watch.
it's a roller coaster.
And then it just finally becomes a sine curve.
Oh my God.
So the sine and the cosine curve are the same values.
Wait, it's
They're just a phase shift out by pi over 2. That's why.
my metaphor. My metaphor.
Isn't that neat? Isn't that kind of fun to watch?
Metaphor is like cosine and
A phase shift is moving the graph left or right. Okay?
I'm gonna make mine.
So check this out. So you can make it a little go faster too.
So if you add pi over 2, is that two sine curve together the cosine curve?
Yes, exactly.
Mirror, butterfly.
Elijah just summed it up. He said if you add a pi over 2 phase shift, you get it to a cosine curve, you get a sine curve.
You subtract it from
Yeah,
the
go ahead.
cosine.
Yep. So there you go. There's the distance to show what's going on there. Kind of fun to see, okay?
I don't get
So Cole just told us that we can rechange our scale on our x-axis. I had it as just set as regular old 1, 2. You can change it to pi over 2. See, now you can see that it bounces back and forth to pi over 2. Dude, that's so sick. Woohoo! Free technology. It's out there. Go find it. Fun. Recording. So what we just saw was that the sine curve and the cosine curve are just the same curve, except they are out of phase, meaning that their phase shift off by pi over 2 from one another, okay? So let's talk about phase shift for just a second, and let's practice graphing a phase shift equation. So we're going to go ahead and, for an example, and graph y equals the cosine of x minus pi over 2. Okay? So if you take a look at that half orange sheet now, you should recognize that the portion that is inside my parentheses tells us that there's a phase shift happening. So a PHS. Yes, it is. Okay? And which direction is this phase shift going? If it's negative, then that means it's going to go pi over 2 units to the right. So the phase shift is going to be pi over 2 units. When I say units, I mean radians. Pi over 2 to the right. So I'm going to show you how to get this graph. This one should look familiar. I'm choosing this one on purpose, okay? So here's how you would draw this, do this homework problem, or do this problem on a test or a quiz using transformations. Okay? If I know I'm going to the right, then I'm going to give myself some room on the right-hand side. So I'm going to draw a normal curve, so from 0 to 2 pi, and I'm going to, of course, put pi in the middle, put pi over 2 on the left, and then a 3 pi over 2, and I'm going to draw a normal cosine curve. Here's -1, and then there's +1. So the normal cosine curve is this. Starts high, goes middle, goes low, middle, and then high again, okay? So that's how we start, that's how we begin, okay? That's a pretty sad looking curve, but you guys get the point. So the first thing that I did was I graphed the parent function cosine of x. Everybody cool with that part? Yeah? Next thing I'm going to do, I'm going to choose a different color now to make it easy for you to see. I'm going to graph the cosine of x minus pi over 2. So that means that each of my 5 dots needs to move pi over 2 radians to the right. So that means this dot needs to come over here. And it has moved a distance of pi over 2 to the right. This dot needs to go here because it has moved pi over 2 to the right. This dot has moved here because it's pi over 2 to the right. This dot would be here. And then finally, to rescale my coordinate, my x-axis, where would that be? 1 pi over 2, 2 pi over 2, 3 pi over 2, 4. So this has to be 5 pi over 2. Do you guys see how I just counted that up really quickly? Yep. Okay. And then, so bring it back. So this point goes here. So this is my new graph right here. And that graph should look familiar to you. It's the same thing as the sine, because if I just connected this on back here and highlighted it, notice that I would have just drawn a sine curve. So it should be no surprise to you that the cosine of x minus pi over 2 is the same thing as sine of x, because it's just exactly what we saw on the Desmos here as well. As soon as I move that cosine over by a value of pi over 2, it becomes the sine curve right like that. And you guys can see I'll just move this over to the right. Okay, same idea. Okay, is this making sense? Yeah, this statement is true. This is the same statement, okay? Okay, ladies and gentlemen, here we go. We're going to do this example together. I want us to graph y equals the cosine of 2x minus pi over 4. Does this look interesting to you? Does this look different to you? Does this look... Yeah, what's going on, right? What's the 2 do, right? This is an issue for us. This is an issue for us. The fact that this 2 is right there is an issue for us. How do we fix this issue? Yes, Brian. We factor it out. We just factor it out, right? We immediately rewrite this statement like this. Y is equal to the cosine of 2 times x minus pi over 8. Whoa, wait a minute. Time out. Where the heck did pi over 8 come from? Rachel. No, all that's still the same. All that's still the same. I'm asking, where does the pi over 8 come from, ladies and gentlemen? Yeah. Because I've factored out a value of 2, right? Exactly. So if I did 2 times x, that would give me the 2x. If I did 2 times pi over 8, that's a pi over 4. So you have to be careful when factoring out a coefficient in front of your variable term. Okay? Now, everything else stays the same. The way it works for a sine curve is the way that it works for a cosine curve. So you guys tell me, what is this value of 2 going to do? That's a period. Very good. Okay, so our period is equal to 2 pi divided by 2, which means we have a full period of pi. So it takes pi radians to go one full circle of this particular cosine curve. Now you guys tell me, what is this pi over 8 business all about? This negative pi over 8 business. Yeah, pi over 8, which direction? To the right. Very good. And what is that called? A phase shift. Very good. A PHS. A phase shift. So we have two transformations that are happening to this particular curve. We have a phase shift and we have a period. According to that little handout I gave you, which one should we do first? We should do the phase shift first, right? That's what it says. Do the phase shift first, okay? So that's what we're going to do. We're going to do the phase shift first and then the period. You do not have to do it that way, but I have found over the many years of teaching it that doing the hardest thing first to the easiest thing makes the whole problem doable, okay? So here we go. Follow along with me, please. So I'm going to go all the way out. I'm going to call this 2 pi for now, okay? I'm going to call that pi. I'm going to call that pi over 2, okay? So that has to be 3 pi over 2. Leave yourself lots of space here, okay? So right here, or how I've done it here. Just kind of make it similar to what I'm doing, okay? The amplitude I know is 1 and negative 1. Easy enough, right? First graph I'm going to do is cosine of x. So what are my 5 points for the cosine of x, everybody? High, yep. Middle, low, middle, high. Good. Okay, so this black line here, this black curve, represents the parent function to my cosine curve, okay? Everybody okay with that part? Talk to me, yeah? Okay, good. Now, in a different color I'm going to choose to make it easy for you to see. I'm going to do the phase shift first. So I'm going to graph the equation y equals cosine of x minus pi over 8. So I have to move those 5 dots pi over 8 radians to the right. Where the heck is pi over 8 radians? Half of a half, right? Of a half, right? So check this out. This point, you guys agree, is pi over 4. True? So then where's pi over 8? So pi over 8 is right here.
So then can we write everything in terms of pi over 8?
Yes, you write everything in terms of pi over 8. Okay? 1 pi over 8, that's what we have. 2 pi over 8. Then I have need another one for 3 pi over 8. You guys see that? And then I finally have a 4 pi over 8. And then I'm going to have 5 pi over 8. 6 pi over 8. I'm just not going to reduce right now. 7 pi over 8. And then finally 8 pi over 8. Okay? And then I'm going to have 9 pi over 8. 10 pi over 8. I'm just going to stop right there for now. Okay? Because I get the gist of what's going on, right? So here we go. Each dot has to move pi over 8 to the right. So that dot goes there, this dot goes there, this dot goes there, this dot goes here a little bit, and this dot would go here. Could I calculate that one on the end there? 2 pi? 2 pi plus a pi over 8, what would that be? 16 pi over 8 plus 1 pi, 17 pi over 8, yeah? So this would be 17 pi over 8. So I could get that point easily, right? Okay. So now I have this blue curve here. So it's gone pi over to the right. Okay? Are we good so far, you guys? Are we good so far? Okay. Now the next thing I need to do is I need to draw, for the third one, I have to put the whole graph together. I have to draw the cosine of 2 times x minus pi over 8. So that means I have to fit the period in a distance of what? A distance of pi. Does everybody realize right now that my graph starts here, excuse me, and ends here. That yellow line that I've drawn for you is how long? 2 pi. It's 2 pi. It's all been moved over pi over 8, right? Because if I do 17 pi over 8 minus 1 pi over 8, I get 16 pi over 8, which is 2 pi. So right now, that yellow distance is a period of 2 pi. I need to draw a full cosine curve on a distance of what? No. Pi. Okay? Because my period, that one that I want, is pi. So if I start at pi over 8, where am I going to end? At 9 pi over 8. That right there is a distance of pi. You guys see it? Because remember, the phase shift has moved us over a little bit, right? So now we calculate pi. Okay, this is easy to do. I'm going to go back to that pink color for my curve here. Remember, I start and I end high on my high points. Do you see that? So it's important to know how to draw the basic cosine curve. Okay, halfway between all of that, looks like 5 pi over 8 to me, right? I will be at my low point here. Do you guys see that? You guys good with that part? Okay, so 1, 2, 3, 4, so 1, 2, so 3 pi over 8 will be a middle point, and 1, 2, 3, oh, sorry, or 5 pi over 3, right? 1, 2, 3, 4, so 1, 2, so over there, 3, there we go. Boom, all the way down, up, and there. Okay.
What are the 2 middle points?
Looks like 3 pi over 8 and 7 pi over 3. Did I do that right? Can you guys verify that for me? Or 8, sorry, 8, not 3. 8, sorry. I'm dealing with 8s here. Does that look good to you guys? Okay, now we're going to check to make sure that we did this correct. We're just going to check, okay? Here's how we check. We go to our calculator. We have to be in radian mode in order to graph a cosine curve. So I'm going to go mode. I'm going to go to radian. Okay? I'm going to go down one more, go to radian, put it in radian mode. Go to y equals. Okay? Put in the exact equation as it was given to us. Cosine of 2x minus, and then a pi divided by 4. Okay? Just as it was given to me like that. Now I need to change the window to make sure I'm doing this correctly, okay? So I'm going to go to the window here. What's my lowest x value that I see? 0, right? My lowest x value is 0. What's my highest x value that I'm seeing here? On this blue curve here? No. 9 pi over 8. See it? 9 pi over 8. Okay. What's my scale that I'm using? Pi over 8. Very good. Pi divided by 8. Very good. What's my lowest y value? And my highest value by 1. Awesome. Okay. I record this. Now I'm going to hit graph. Okay. And, whoo, check it out. Now we're on the right page here. So, look, if I go over 1 unit, remember, oh, what happened to my, it does this a lot. I don't know why. Okay. Whoa. Here we go. Okay. If I go over 1 unit at pi over 8, I should be at a maximum of 1. So check it out. If I go over to pi over 8, I'm at a maximum of 1. If I count over 1, 2, 3 intervals of pi over 8, I should be at an intercept. Count over 1, 2, 3 intervals, and I have an intercept. I know I did this right then. Okay? Yeah, go ahead, graph this one. Cosine 2x plus pi over 2.